Hi guys, we decided to do a projectile motion problem involving cliff jumping. Here's the problem.
A man decides to jump off a 60-foot cliff. He needs to clear 10 feet of rocks to make it to the water. If he runs off at 10 miles an hour, how far from the base of the cliff does he land? Does he clear the rocks? How fast is he going when he hits the water?
Here's the setup. The guy is standing on a 60-foot cliff and he has to clear 10 feet of rocks to hit the water. He's running at 10 miles an hour. Part A, distance.
The two equations that are needed for part A of this problem are x of t equals 1/2 axt squared plus v naught xt plus x naught, and y of t equals negative 1/2 gravity t squared plus v naught y t plus y naught. The knowns, the height is 60 feet, which is 18.3 meters. We need to clear 10 feet, which is 3.5 meters, and we are leaving the cliff at 10 miles an hour, or 4.47 meters per second. To start, we need to solve for the amount of time we are in the air. To do this, we will take the first equation, y of t equals negative 1/2 gt squared plus v naught y t plus y naught. There is no initial velocity in the y direction, so this whole part goes to 0. So you're left with negative 1/2, negative 9.8 meters per second squared, the acceleration due to gravity, times time squared, plus 0, plus 18.3 meters, which is the initial height. This simplifies to negative 4.9 t squared plus 18.3, which will give us a time of 1.93 seconds. We then take our second equation, x of t equals 1/2 at squared plus v naught xt plus x naught. The acceleration in the x direction is 0, so this whole part goes to 0, and the initial x position is also 0. So we're just left with this part of the equation. Velocity not in the x direction is 4.47 meters per second. The time is 1.93. So we are going to land 8.63 meters out from 0. We have to clear 3.05 meters. So we are going to land 5.58 meters from the rocks. So he will clear the rocks.
Part B, his speed.
To find his velocity when he hits the water, we use this equation, which is the velocity is equal to the acceleration due to gravity times time plus the velocity not in the y direction. We know the time is 1.93 seconds and velocity not is 0. So take negative 9.8 meters per second squared, which is gravity, times 1.93 seconds in the air, and we get 18.914 meters per second when he hits the water.